All right, let's talk about section 3.3. So I've already drawn a few things here. So for 3.3, we're looking at nodal analysis with a voltage source. Let's look at case 1 here. In this one, we have our node here, and we have our reference node here. So this is a non-reference node and our reference node ground. We have a voltage source between those two. In that case, it's very easy. All we need to do is write that Vn is equal to Vs. Done. It doesn't matter what else is connected here, okay? You can have 27 different resistors going up off of this, a house and a cat and a dog. Doesn't matter. Because this source is here between this node and the reference node, we know that Vn is equal to Vs. Write that down, stop doing stuff, okay? People always want to get creative and do more than that. You don't need to. Now let's look at case 2. Case 2 is a bit more complicated. So in case 2, I have 2 non-reference nodes, so some other stuff down here, don't care what it is, and a voltage source in the middle of those. When you see this, what you do is make a supernode. So I can combine Vx and Vy. I call it a supernode. And I write one nodal equation that involves both Vx and Vy. When you do that, we'll show an example of it too. When you do that, you fall one equation short of being able to solve the simultaneous equations. And you get that last equation from inside the supernode. So remember, our simple example, if I have VB and I have VA, the voltage across here is VA minus VB. Right? I've shown that several times now. Over here, on the plus side, I have Vx, minus side Vy. That's going to be equal to Vs. So that'll be the last equation you need to be able to solve any problem that involves a case 2. So let's look up here at this one. This is practice problem 3.3. And we notice right away that we have a voltage source between 2 non-reference nodes. So let's go ahead and name these. Name this V1. And let's name this, remember this is all one node, V2. And I could label this V3 if I wanted to, but we know what it's equal to, right? This is a case 1. So if I labeled this V3, I would know V3 equals 21 volts. So I have 21 volts at this node. This is a case 1. This is a case 2. And this falls between 2 non-reference nodes. So this is making up a supernode. So here's how we deal with that. I want to write my equation starting at V1. So I'm writing my nodal equation like we did in the last section. I have V1 minus 21 volts divided by 4 plus V1 minus 0 divided by 3. And then I'm stuck, right? There's nothing I can do here. So if you didn't recognize the supernode at first, hopefully you will when you start working the problem, because when you get here, you'll go, I don't know what to do. Oh, maybe it's a supernode, okay? There's nothing else we can do here, so we hop over to V2. Remember, we're treating this as one node, one supernode. So I continue writing the same equation. Plus V2 minus 0 over 2 plus V2 minus 0 over 6 equals 0. Did you put these two in parallel and have one resistor here? Yes. But I don't see a big advantage of doing that. I just left it as it is. Okay, so that's my supernode. That's involving both V1 and V2, one big supernode. So we want to reduce this equation, multiply through by 6, combine like terms. I've already done that on here. So what we end up with is 7V1 plus 8 V2 equals 63. So I have one equation and 2 unknowns. That's why we need to do, squeaky marker, we need to do this. what's on the plus side? V2. So V2 minus V1 equals the value, 9. I can't take that marker anymore. So here I have 2 equations and 2 unknowns. So I can solve those in any way that you want. You'll get a V1 that's negative 0.6 volts, a V2 that's equal to 8.4 volts, and we'd be done if that's what the problem had asked for, but what they actually asked us for is V and I. So the voltage across here, V, well that is V1, right? That's the same thing. Voltage across here is V1, V1 minus 0. So V is equal to V1. So there's our answer for that. For the current I, we need to do Ohm's law. V equal IR. V2 equals I times 2. Or I equal V2 over 2, or 4.2 amps. That's the second thing that the problem had asked for. So that is nodal analysis with voltage sources. A quick note, this had 2 nodes that combined to make a supernode. We can have 3 or 4 or 5, it doesn't matter. If I have another source off of here, and some other stuff, well now I've got a supernode between these 2, so I'd have 1 giant supernode. So it's not limited to just 2 nodes. It can be up to 3, well not up to anything, it can be unlimited. But in the problems you'll see, the practical problems in the back of the book, I think 3 would be the max that you're going to see in Circuits 1.